Hey everyone, welcome back to Bugnojutsu. Today we're tackling a really fun and simple LeetCode problem, 1323. Maximum 69 number. Even though it looks straightforward, it's one of those problems that helps you understand greedy thinking and how a small change in logic can maximize results. So let's dive in and break it down step by step. We are given a positive integer that consists only of the digits 6 and 9. Our task is to return the maximum number possible by changing at most one digit. The digit change is restricted in such a way that we can flip a 6 into a 9 or a 9 into a 6. Now, if we think about it, the problem is basically asking us, what's the best position to make a single change so that the overall number becomes as large as possible? Since the digits are only 6 and 9, it's clear that changing a 6 into a 9 will always increase the number, whereas flipping a 9 into a 6 would reduce it. So the optimal strategy revolves around finding the first 6 from the left and flipping it into a 9. Let's walk through the example given in the problem. Number equals 9669. If we flip the first digit from 9 to 6, we get 6669. Notice this is smaller than the original, so not a good move. If we flip the second digit, the number becomes 9969. That's a great improvement, because we've increased the tens place, and that contributes a lot to the overall value. If we flip the third digit, the number becomes 9699. That's still larger than the original, but not as large as 9969. If we flip the last digit, we get 9666, which is definitely worse. Among all these possibilities, the largest number we can make is 9969. And the way we achieved it was by flipping the first 6 we saw from the left side. That's not a coincidence. It's a pattern. Because digits toward the left are more significant, flipping the leftmost 6 always gives the best increase. It's like getting the maximum bang for your buck, make the change where it matters most. Now let's talk about the method I used to solve this. It's actually very intuitive once you think about it. First, I convert the number into a list of characters. Why? Because strings and lists in Python allow us to easily check each digit and modify it when needed. If we keep the number in integer form, modifying one digit directly is messy. But once it's a list of digits, changing a single one is super straightforward. Next, I loop through the list from left to right. I'm scanning digit by digit, looking for the first occurrence of 6. The moment I find a 6, I flip it into a 9. And here's the important part, I stop immediately. Why? Because once we flip the first 6, we've already made the number as large as possible with just one change. There's no need to flip anything else. Finally, I join the digits back into a string, convert it back into an integer, and return it. This method is neat and ensures that we follow the greedy strategy perfectly, maximize the most significant digit first. In terms of complexity, the solution is extremely efficient. Since the number has at most 4 digits, the loop only runs a few steps. So the time complexity is O(d), where d is the number of digits, but practically it's constant time, O(1). The space complexity is also O(1), because we're only using a small list to hold the digits temporarily. One key insight here is the greedy nature of the problem. The first 6 from the left is the most valuable one to flip, because digits on the left contribute more to the overall value of the number. This is a classic greedy approach where making the best local choice gives you the best overall solution. Another insight is how even a very simple problem can be solved in different ways, using strings, arrays, or even pure math, depending on how creative you want to be. And that's it for today's problem. We walked through how to turn a number made of 6s and 9s into the largest possible value with just one simple flip. If you found this explanation helpful, don't forget to like the video, subscribe to Bugnojutsu, and hit the bell icon so you won't miss out on more problem-solving strategies and coding insights. Thanks for watching, and I'll see you in the next one.